I want you to do something for me. Picture a mountain. Go on, get a really clear image in your head. Maybe it's got a snowy peak, jagged rocks. Got it? Okay, because we're about to find out if what you're picturing is even close to the real thing. So, what did you see? I'm guessing it was some giant peak, right? Reaching up for the sky? Well, what if I told you that our common idea of a mountain is just wrong? That what we see is only a tiny, tiny fraction of its true size. I mean, if you had to sketch it, you'd probably draw something like this, wouldn't you? A simple triangle sitting on a flat line. And that's totally fair. For basically all of human history, that's exactly how we saw mountains, as just these giant piles of rocks sitting on top of the ground. But here's the thing, that simple drawing, it only shows the very, very tip of the story. The real action, what truly makes a mountain, is happening deep, deep beneath the surface, completely hidden from our view. You know, the best way to think about it is like an iceberg. Yeah, seriously. For every bit of mountain you see towering above the ground, there's a much, much larger part extending deep into the earth that we can't see at all. And this isn't some ancient piece of wisdom. This idea is actually pretty recent. It all came to light in the 19th century, thanks to a geological theory that was a total game changer. It's called Isostasy, and it revealed this incredible hidden world right under our feet. Now, isostasy sounds really complicated, I know, but the core idea is pretty simple. Back in the 1800s, geologists noticed that gravity was acting, well, kind of weird around big mountain ranges. This led them to a wild idea. The Earth's crust isn't one solid shell. Nope. It's broken up into these massive plates that are basically floating on the hot, semi-fluid mantle below. So just like an iceberg in water, the really heavy, thick parts, like mountains, have to have huge, deep roots sinking way down to stay balanced. To really wrap your head around this, let's look at Mount Everest. We all celebrate its incredible height, right? About 8.8 kilometers above sea level. But that's just the part we see. The unseen part, its hidden root, plunges an astonishing 125 kilometers deep into the earth. Let me say that again. The hidden part of Everest is more than 14 times deeper than the part we call the highest mountain on Earth. It's just staggering. And this chart just lays it all out. Look at that tiny little bar for the visible part of Everest. Now look at the massive bar for its hidden root. It's not just a little bigger, it's on a completely different scale. The mountain we see is literally just the tip of the true structure. So what's the point of these enormous roots? Well, they have an absolutely crucial job. They act like giant anchors. They literally pin the Earth's crust down into the mantle below, giving the tectonic plates immense stability. Without them, things would be a lot more shaky. Now, keep that word in mind, anchors. It's going to be important. Okay, so this whole understanding of mountains as deep, stabilizing anchors is a fairly recent scientific discovery. And this is where our story takes a really fascinating turn. We're going to jump back in time, about 1400 years, to an ancient text that describes this exact function with remarkable precision. This quote comes from the Quran, in chapter 78. It poses a question. Have we not made the earth a resting place and the mountains as stakes/pegs? That last part is the key. The word there, translated as stakes or pegs, is the original Arabic word Awtad. Now, Awtad isn't a vague term. It's very specific. It means the kind of stakes or pegs you'd hammer deep into the ground to anchor a big tent. So just think about that object. Its entire purpose is stability and anchoring. So this raises a really interesting question. Is this just a simple visual metaphor, a bit of poetry, or is it something much more precise, a functional, almost an engineering analogy? The immediate skeptical take is pretty straightforward, right? People back then used tent pegs, and mountains can look kind of pointy, like the tip of a stake. So it must be a simple visual comparison, just a poetic description based on what they could see. But let's really think about that for a second. Does a massive, pyramid-shaped mountain actually look like a long, thin tent peg? Not really. And more importantly, what is the true function of a peg? Is its value in the small, pointy tip that you can see? Or is it in something else entirely? When you break it down like this, the visual analogy just falls apart. A mountain is a giant pyramid. A peg is a thin rod. It's a clear mismatch. But when you look at the main function, anchoring a large, unstable structure, it's a perfect match. And what about its location?
A peg's entire utility comes from being mostly buried underground, and as modern geology just showed us, so does a mountain's. Another perfect match.
So you see, the analogy isn't about the visible shape at all. It's all about hidden depth and function. A tent peg's value isn't in its pointy tip. It's in the buried length that provides all the stability. The description of mountains as pegs becomes incredibly precise only when you understand the unseen root and its anchoring role, a scientific reality that was completely unknown when this text was written. So when you place these two threads side by side, modern geological science and this ancient description, you find this striking parallel. Both are describing the exact same hidden reality of mountains acting as anchors for the Earth.
The crucial point is this. For millennia, humanity saw mountains as giant paperweights, just sitting on the surface. Then, modern science proved they are actually anchors, with deep roots providing stability from below. And somehow, an ancient text used the perfect engineering term for that exact function, a peg.
So just think about the path we've taken. We started with our common surface-level view of mountains as simple piles of rock. Then we dove beneath the surface with modern science to discover their deep, stabilizing roots. And finally, we found an ancient text describing them not by what they look like, but by what they do, acting as pegs, a perfect functional description of that hidden reality. It really leaves you with a compelling thought, doesn't it? If a description of a modern geological discovery was waiting in a 1,400-year-old text described with such functional precision, it just makes you ask, what other knowledge might be hiding in plain sight, waiting just beneath the surface for us to uncover?